More than 2,500 years ago, a Greek philosopher named Anaximander dared to suggest something extraordinary, that our world was not alone. He spoke of infinite worlds, countless realities coexisting beyond the limits of human perception. At the time, his ideas were dismissed as the stuff of myth, a flight of imagination too grand to be taken seriously. But what if he was onto something? What if the ancient myths of multiple worlds weren't just stories, but early glimpses of a truth we're only now beginning to unravel? Today, the idea of a multiverse, a vast, interconnected web of universes, has moved from the realm of mythology to the cutting edge of science. Theories like string theory and quantum mechanics suggest that our universe might be just one thread in an infinite cosmic tapestry. But this isn't just a story about science. It's a journey through time, tracing humanity's relentless quest to understand the cosmos. From the myths of ancient civilizations to the mind-bending discoveries of modern physics, the concept of the multiverse has fascinated and eluded us for millennia. So, what if our universe is just one of many? What if the answers to the greatest mysteries of existence lie not in the stars above, but in the vast, unseen dimensions beyond? Join me as we explore the untold histories of the multiverse, where ancient myths meet modern science, and where the boundaries of reality are constantly being redefined. Long before telescopes or particle accelerators, ancient civilizations were already peering into the mysteries of existence, imagining realities far beyond the confines of their own world. In the rich tapestry of Hindu cosmology, the Puranas, sacred texts dating back thousands of years, paint a breathtaking picture of the multiverse. They describe an infinite number of universes, each floating like bubbles in a vast cosmic ocean, endlessly rising and dissolving in a cycle of creation and destruction. These universes, or lokas, are said to be governed by their own laws, their own gods, and their own destinies. It's a vision that feels strikingly modern, yet it emerged from a time when humanity's understanding of the cosmos was still in its infancy. What's remarkable is how these ancient thinkers didn't just imagine other worlds, they saw them as part of a grand, interconnected whole, a concept that resonates deeply with today's multiverse theories. Meanwhile, across the Mediterranean, Greek philosophers were grappling with similar ideas. Take Democritus, for instance, the father of atomic theory. He proposed that the universe was made up of an infinite number of atoms colliding in an infinite void, giving rise to an infinite number of worlds. His contemporary, Epicurus, took this idea even further, suggesting that these worlds were not only infinite but also varied, some thriving with life, others barren and desolate. For these thinkers, the idea of multiple worlds wasn't just a philosophical exercise. It was a way to make sense of the vastness and complexity of existence. They saw the cosmos as a place of endless possibility, where every imaginable reality could exist somewhere in the infinite expanse. What's striking about these ancient visions is how they blend the poetic with the profound. The Hindu cosmic ocean, the Greek infinite void, these weren't just metaphors. They were attempts to grapple with the sheer scale of existence, to find meaning in the chaos of the universe. And while these ideas were born in a time when science as we know it didn't exist, they laid the groundwork for the questions we're still asking today. How did the universe begin? Are we alone? And if there are other worlds out there, what might they be like? These early multiverse theories weren't just flights of fancy. They were expressions of humanity's innate curiosity, a desire to push beyond the limits of what we can see and touch. They remind us that the quest to understand the cosmos isn't a modern invention, it's as old as civilization itself. And as we'll see, this ancient fascination with multiple worlds would echo through the centuries, shaping the way we think about the universe and our place within it. As the ancient world gave way to the medieval era, the idea of multiple worlds didn't fade. It evolved. In the halls of monasteries and the libraries of Islamic scholars, the question of the multiverse became a topic of deep philosophical and theological debate. Medieval thinkers, often seen as bound by dogma, were in fact wrestling with questions that would later shape the foundations of modern science. Take Thomas Aquinas, one of the most influential theologians of the Middle Ages. In his monumental work, Summa Theologica, Aquinas pondered whether God could create more than one universe. His conclusion: if God is infinite in power and creativity, why limit creation to just one world? Since God's power is infinite, he wrote, it is not impossible for him to create other worlds. For Aquinas, the multiverse wasn't a threat to faith, it was a testament to the boundless nature of divine creation. Meanwhile, in the Islamic Golden Age, scholars like Al-Farabi were exploring similar ideas through the lens of philosophy and cosmology. Al-Farabi, often called the second teacher after Aristotle, envisioned a universe filled with multiple realms, each governed by its own set of natural laws. In his work, The Virtuous City, he described a hierarchical cosmos where worlds existed in harmony, reflecting the order and wisdom of the Creator. For Al-Farabi, the multiverse wasn't just a philosophical concept, it was a way to understand the unity and diversity of existence. His ideas bridged the gap between faith and reason, showing that the pursuit of knowledge could be both a spiritual and intellectual endeavor. These medieval debates weren't just abstract musings, they were part of a broader shift in how humanity understood the cosmos. Theologians and philosophers alike were grappling with a profound question. If the universe is a reflection of divine power, could there be more than one? Some argued that a single universe was sufficient to demonstrate God's glory, while others saw the possibility of multiple worlds as evidence of his infinite creativity. These discussions weren't just about theology, they were about the very nature of reality. Could the universe contain infinite possibilities? And if so, what did that mean for humanity's place within it? What's fascinating about this period is how these thinkers navigated the tension between faith and reason. They didn't see science and religion as opposing forces. Instead, they sought to reconcile the two, using logic and scripture to explore the mysteries of existence. A quote from the medieval scholar Robert Grosseteste captures this spirit perfectly. The investigation of nature is the investigation of the divine. For Grosseteste and his contemporaries, studying the cosmos wasn't just an academic exercise, it was a way to glimpse the mind of God. This medieval curiosity laid the groundwork for the scientific revolutions that would follow. By asking whether the universe could contain multiple worlds, these thinkers opened the door to new ways of understanding reality. They showed that the cosmos wasn't a static, unchanging entity, but a dynamic, evolving system filled with infinite possibilities. And while their tools were limited by the knowledge of their time, their questions were timeless questions we're still grappling with today. How vast is the universe? Are there other worlds beyond our own? And what does it mean to exist in a cosmos that might be more complex than we can imagine? These medieval debates remind us that the search for answers is as much a journey of the mind as it is of the soul. The Renaissance was a time of rebirth, not just for art and culture, but for humanity's understanding of the cosmos. As Europe emerged from the Middle Ages, a new spirit of inquiry began to take hold, challenging old assumptions and sparking bold new ideas about the universe. Among these thinkers was Giordano Bruno, a philosopher and astronomer whose vision of the cosmos was as radical as it was breathtaking. Bruno didn't just believe in other worlds, he argued that the universe was infinite, filled with countless stars, each with its own planets and civilizations. Innumerable suns exist, he wrote, innumerable Earths revolve around these suns in a manner similar to the way our planets revolve around our sun. For Bruno, the idea of a single Earth-centered universe wasn't just outdated, it was unimaginably small. His vision of an infinite multiverse was a radical departure from the prevailing worldview, and it came at a cost. Bruno's ideas didn't sit well with the Church, which saw his theories as a direct challenge to its authority. In 1600, after years of persecution, Bruno was tried for heresy and burned at the stake. His death was a stark reminder of the dangers of questioning the status quo, but his ideas refused to die with him. Bruno's vision of an infinite universe laid the groundwork for the scientific revolution, inspiring later pioneers like Galileo Galilei and Isaac Newton. Galileo, with his telescope, would go on to confirm that the heavens were far more complex than anyone had imagined, while Newton's laws of motion and universal gravitation provided a framework for understanding the forces that govern the cosmos. Together, these thinkers helped shift humanity's perspective from a mythological view of the universe to one rooted in observation and evidence. What's fascinating about this period is how it marked a turning point in the way we think about the cosmos. The Renaissance wasn't just about rediscovering ancient knowledge, it was about pushing beyond it, using reason and experimentation to explore new frontiers. Figures like Bruno, Galileo, and Newton didn't just accept the world as it was, they questioned it, tested it, and reimagined it. Their work transformed the multiverse from a philosophical idea into a scientific possibility, setting the stage for centuries of discovery. But the Renaissance wasn't just a time of scientific progress, it was also a time of conflict. The clash between new ideas and old beliefs was often violent, as Bruno's tragic fate reminds us. Yet, even in the face of opposition, the spirit of curiosity and exploration prevailed. The Renaissance taught us that progress isn't always easy, but it's always worth pursuing. And as we'll see, this spirit of inquiry would continue to shape our understanding of the universe, leading us to ask even deeper questions about the nature of reality itself. The Enlightenment marked a seismic shift in how humanity viewed the cosmos, a time when reason and observation began to eclipse myth and dogma. At the heart of this intellectual revolution was Immanuel Kant, a philosopher whose ideas about the universe were as profound as they were visionary. Kant proposed that the Milky Way was just one of countless island universes, each a vast collection of stars separated by unimaginable distances. His vision of an infinite cosmos challenged the notion that Earth, or even our galaxy, was the center of everything. Instead, Kant saw the universe as a boundless expanse, filled with worlds upon worlds, each a stage for the drama of existence. His ideas weren't just philosophical musings, they were a call to rethink humanity's place in the grand scheme of things. This era also saw the emergence of astronomy as a tool for exploration, not just observation. In the late 18th century, the astronomer William Herschel used his telescope to map the night sky, discovering thousands of nebulae, faint, cloudy patches of light that hinted at structures far beyond the Milky Way. Herschel's work laid the groundwork for a startling realization: our galaxy wasn't alone. These nebulae, he speculated, might be distant galaxies, each a swirling island of stars much like our own. It was a revelation that expanded the scale of the universe beyond anything humanity had ever imagined. Suddenly, the cosmos wasn't just vast, it was infinite, filled with possibilities that stretched the boundaries of human understanding. But what did this mean for our understanding of life itself? If the universe was infinite, did that mean other worlds could harbor life? This question became a central theme of Enlightenment thought. Philosophers and scientists alike began to speculate about the existence of extraterrestrial civilizations. Kant himself suggested that other planets might be home to beings as complex and intelligent as humans, each shaped by their own unique environments. For thinkers of the time, the idea of life beyond Earth wasn't just a scientific curiosity, it was a philosophical imperative. If the universe was infinite, then life, too, must be infinite, scattered across countless worlds in an endless tapestry of existence. This shift in perspective had profound implications. It forced humanity to confront the possibility that we weren't alone, that the universe might be teeming with life, each civilization a thread in the cosmic fabric. It also challenged the notion of human exceptionalism, suggesting that our world was just one among many, each with its own story to tell. This humbling realization was both exhilarating and unsettling, a reminder of how small we are in the face of the infinite. The Enlightenment didn't just expand our understanding of the universe, it redefined how we thought about our place within it. By embracing the idea of an infinite cosmos, thinkers of the era opened the door to new questions about the nature of life, the limits of knowledge, and the very meaning of existence. And as we'll see, this spirit of inquiry would continue to shape our exploration of the cosmos, leading us to even greater discoveries in the centuries to come. But the Enlightenment wasn't just about looking outward, it was also about looking inward. As humanity grappled with the enormity of the universe, it also began to question its own assumptions about reality. What did it mean to exist in a cosmos that might be infinite? Could there be truths beyond what we could observe or comprehend? These questions weren't just academic, they were deeply personal, forcing individuals to confront their own beliefs and biases. In this way, the Enlightenment wasn't just a scientific revolution. It was a philosophical one, a journey of discovery that continues to shape our understanding of the universe and ourselves. As the 19th century gave way to the 20th, humanity's understanding of the universe underwent a revolution unlike any before. This was the dawn of quantum mechanics, a field that would forever change how we see reality. At its core, quantum mechanics revealed a world that defied common sense, a world where particles could exist in multiple states at once, where observation could alter outcomes, and where the very fabric of reality seemed to shimmer with uncertainty. But perhaps the most astonishing idea to emerge from this era was the concept of parallel universes, a theory that would challenge everything we thought we knew about existence. Enter Hugh Everett, a young physicist who, in the 1950s, proposed a radical idea known as the many worlds interpretation. Everett's theory suggested that every time a decision is made, no matter how small, the universe splits into multiple branches, each representing a different outcome. Think of it like a tree with countless branches, each one a new reality. In one branch, you might choose to take a different route to work. In another, an entirely different life unfolds based on that single choice. According to Everett, these parallel universes aren't just abstract possibilities, they're real, coexisting alongside our own, invisible yet ever-present. To grasp this mind-bending idea, imagine standing at a crossroads. Every path you could take leads to a different destination, and each destination represents a unique universe. In one universe, you turn left and meet a friend. In another, you turn right and stumble upon an unexpected opportunity. The many worlds interpretation suggests that all these possibilities exist simultaneously, each one playing out in its own distinct reality. It's a concept that feels more like science fiction than science, yet it's grounded in the rigorous mathematics of quantum mechanics. But why would the universe work this way? At the heart of quantum mechanics is the idea of superposition, where particles exist in multiple states until they're observed. Everett's theory takes this a step further, proposing that every possible outcome of a quantum event actually happens just in different universes. This means that every time an electron spins in one direction, or a photon behaves like a wave or a particle, the universe splits, creating a new reality where the alternative outcome occurs. The implications are staggering: an infinite number of universes, each branching off from the last, forming a vast, ever-expanding multiverse. What's fascinating is how this idea resonates with earlier notions of the multiverse, from the Hindu lokas to the infinite worlds of Democritus. In a way, the many worlds interpretation is a modern echo of these ancient ideas, reimagined through the lens of quantum physics. Yet it also pushes the concept further, suggesting that the multiverse isn't just a collection of distant worlds, it's a dynamic, ever-changing network of realities, each one shaped by the choices we make. Of course, the many worlds interpretation isn't without its critics. Some argue that it's an extravagant solution to a problem that could be explained more simply. Others question how we could ever test or observe these parallel universes, given that they exist beyond our own reality. But for many, the theory's elegance lies in its simplicity. It provides a framework for understanding the strange, unpredictable nature of quantum mechanics without resorting to paradoxes or contradictions. What's undeniable is how this idea has captured the imagination of scientists and storytellers alike. From blockbuster movies to thought-provoking novels, the concept of parallel universes has become a cultural touchstone, a way to explore the endless possibilities of existence. It challenges us to think beyond the limits of our own reality, to consider what might lie just beyond the horizon of our perception. As we stand on the threshold of the 21st century, the many worlds interpretation reminds us that the universe is far stranger and far more wondrous than we could ever imagine. It invites us to ask not just what is, but what could be. What choices have we made, and what realities have we left behind? And in the vast, branching tapestry of the multiverse, what other versions of ourselves might be out there, living lives we can only dream of? These questions don't just challenge our understanding of the cosmos, they challenge us to rethink our place within it, to see ourselves not as isolated beings, but as part of an infinite web of possibilities. While quantum mechanics introduced the idea of parallel universes, another groundbreaking theory has taken the concept of the multiverse to even greater heights: string theory. Imagine the universe not as a collection of particles, but as a symphony of vibrating strings, each note representing a different particle or force. This is the essence of string theory, a framework that seeks to unify all the fundamental forces of nature into a single, elegant equation. But here's where it gets truly mind-bending. String theory doesn't just describe our universe, it suggests the existence of countless others, each vibrating to its own unique tune. At the heart of string theory is the idea of extra dimensions. While we're familiar with the 3 dimensions of space and 1 of time, string theory proposes that there are at least 6 more dimensions curled up so tightly that we can't perceive them. Think of these hidden dimensions like the folds of a paper fan, too small to see from a distance, but essential to the structure of the fan itself. These extra dimensions aren't just mathematical curiosities, they could be the key to understanding how multiple universes exist side by side. In this view, our universe might be just one brain, a membrane-like structure floating in a higher dimensional space, with other brains representing separate universes, each with its own set of physical laws. This idea, known as the brain multiverse, offers a tantalizing possibility that collisions between these brains could have sparked events like the Big Bang, creating new universes in the process. It's a cosmic dance of creation and destruction, with universes constantly forming, colliding, and evolving. But what would these other universes be like? Some might be eerily similar to our own, with stars, planets, and even life. Others could be utterly alien, governed by entirely different forces and constants. The possibilities are as vast as the multiverse itself. Yet, for all its elegance, string theory faces significant challenges. One of the biggest is the lack of experimental evidence. Because these extra dimensions are so tiny and tightly wound, they're nearly impossible to detect with current technology. And while the math of string theory is beautiful, it's also incredibly complex, making it difficult to derive testable predictions. This has led to heated debates within the scientific community. Some argue that string theory is a mathematical playground too abstract to ever be proven. Others see it as the best hope for a theory of everything, a framework that could finally explain all the forces and particles in the universe. Despite these challenges, string theory has inspired a wealth of new ideas and questions. It's forced scientists to rethink the very nature of reality, to consider that our universe might be just one thread in a vast cosmic tapestry. And while we may not yet have the tools to test these ideas, the very possibility of a multiverse challenges us to expand our horizons, to imagine a cosmos far richer and more complex than we ever thought possible. What's remarkable is how string theory bridges the gap between the ancient and the modern. Just as Hindu cosmology envisioned a multiverse of floating worlds, string theory suggests a cosmos filled with infinite possibilities, each universe a unique expression of the fundamental laws of physics. It's a reminder that the quest to understand the universe is a journey that spans millennia, connecting the myths of the past with the science of the future. As we continue to explore these ideas, we're not just searching for answers, we're redefining what it means to ask the right questions. What lies beyond the limits of our universe? Are there other realities, other versions of ourselves, existing in dimensions we can't yet perceive? And if so, what does that mean for our understanding of existence? These are the questions that drive us forward, pushing the boundaries of knowledge and imagination. And in the end, that's what makes the multiverse so captivating, not just the answers it might hold, but the endless possibilities it inspires. The story of the multiverse takes another astonishing turn with the theory of cosmic inflation, a concept that reshapes how we think about the birth of the universe itself. Picture this: in the first unimaginably tiny fraction of a second after the Big Bang, the universe didn't just expand, it exploded outward faster than the speed of light. This wasn't a gentle growth, it was a cosmic eruption, stretching space itself like a balloon, inflating to trillions of times its original size in less than a blink of an eye. This rapid expansion, known as cosmic inflation, didn't just create the universe we know, it may have also sown the seeds for countless others. Imagine a pot of boiling water, with bubbles constantly forming and rising to the surface. Each bubble represents a universe expanding and growing independently of the others. In this cosmic foam, our universe is just one bubble among many, each with its own unique set of physical laws and constants. Some bubbles might have gravity so weak that stars never form, while others could be so dense that black holes dominate every corner. This is the essence of the inflationary multiverse, a vast, bubbling sea of universes, each one a self-contained reality with its own rules and possibilities. The idea of cosmic inflation emerged in the 1980s, proposed by physicist Alan Guth as a solution to some of the Big Bang's biggest puzzles. Why is the universe so uniform in temperature, even in regions that could never have interacted? And why does space appear so flat rather than curved? Inflation answers these questions by suggesting that the early universe underwent a period of exponential expansion, smoothing out irregularities and flattening space like a cosmic iron. But here's the twist: once inflation starts, it doesn't stop everywhere at once. In some regions, it slows down, allowing matter and energy to coalesce into galaxies and stars, forming a universe like ours. In others, it continues indefinitely, creating new bubbles of space-time that become separate universes. This theory doesn't just explain the structure of our universe, it opens the door to an infinite number of others. Some physicists like Andre Linde have taken this idea even further, proposing that inflation isn't a one-time event but an eternal process, constantly giving birth to new universes. In this eternal inflation model, the multiverse isn't a static collection of bubbles, it's a dynamic, ever-growing ecosystem, with new universes constantly budding off from the old. It's a breathtaking vision of a cosmos that's not just vast but endlessly creative, a place where the laws of physics themselves can vary from one bubble to the next. But how do we know if this is more than just a beautiful idea? While cosmic inflation is supported by observations like the cosmic microwave background, the afterglow of the Big Bang, the existence of other universes remains speculative. After all, if these bubbles are entirely separate from our own, how could we ever detect them? Some scientists suggest that collisions between universes might leave faint imprints in the cosmic microwave background, like ripples in a pond. Others look to the unique signatures of gravitational waves, hoping to find evidence of inflation's explosive beginnings. For now, these ideas remain on the frontier of science, tantalizing hints of a multiverse that might lie just beyond our reach. What's striking about cosmic inflation is how it connects the ancient and the modern. The idea of a multiverse, once the realm of myth and philosophy, has found a home in the equations of theoretical physics. It's a reminder that the questions we ask about the cosmos, its origins, its structure, its possibilities, are timeless, transcending the boundaries of culture and discipline. Whether we're looking at the bubbles in a pot of boiling water or the equations on a chalkboard, the underlying message is the same. The universe is far stranger, far grander, and far more interconnected than we ever imagined. As we explore these ideas, we're not just mapping the boundaries of the cosmos, we're mapping the boundaries of our own understanding. What lies beyond the edge of our universe? Are there other realities, other worlds, other versions of ourselves existing in bubbles we'll never see? These are the questions that drive us forward, pushing the limits of science and imagination. And in the end, that's what makes the multiverse so compelling, not just as a scientific theory, but as a story. It's a story of infinite possibilities, of a cosmos that's always expanding, always evolving, always surprising us with its complexity and beauty. As we peer deeper into the cosmos, we encounter two of the most enigmatic forces shaping the universe: dark matter and dark energy. Together, they make up an astonishing 95% of everything that exists, yet they remain invisible to our eyes and instruments. Dark matter, an unseen substance that binds galaxies together, and dark energy, a mysterious force driving the universe's accelerated expansion, are not just curiosities. They might hold the key to understanding the very fabric of the multiverse. Imagine the universe as a vast, invisible web. Dark matter is the scaffolding that holds this web together, providing the gravitational glue that allows galaxies to form and cluster. Without it, stars and planets would never have come into existence. But dark energy is the wild card, a force that seems to work against gravity, pushing galaxies apart at an ever-increasing rate. This cosmic tug-of-war between dark matter and dark energy doesn't just shape our universe, it could also shape the multiverse. Some theories suggest that these forces might not be confined to our reality. Instead, they could extend into other universes, influencing their structure and even enabling connections between them. One intriguing idea is that dark energy could be responsible for creating new universes. In regions where dark energy dominates, space might expand so rapidly that it tears apart, forming bubbles of new universes. Picture a pot of water boiling over, with bubbles constantly forming and bursting. In this scenario, each bubble is a new universe born from the interplay of dark energy and the fabric of space-time. These universes could have entirely different properties, some with more dark energy, others with less, each one a unique experiment in the laws of physics. But what about dark matter? Could it play a role in connecting these universes? Some physicists speculate that dark matter might form bridges or cosmic filaments between universes, allowing subtle interactions across the multiverse. These filaments could act like invisible highways, transporting energy or information from one universe to another. While this idea is still speculative, it opens up fascinating possibilities. Could dark matter be the thread that weaves the multiverse together, creating a network of interconnected realities? The interplay between dark matter and dark energy also raises profound questions about the nature of existence itself. Why do these forces exist in the precise amounts they do? Some scientists argue that their values are finely tuned to allow life to exist, a concept known as the Anthropic principle. If the multiverse contains an infinite number of universes, each with different amounts of dark matter and dark energy, it's possible that only a tiny fraction would have the right conditions for life. In this view, our universe isn't special, it's just one among countless possibilities, a lucky roll of the cosmic dice. Yet, despite the tantalizing theories, dark matter and dark energy remain shrouded in mystery. We've never directly detected dark matter, and dark energy's true nature is still elusive. This uncertainty is both frustrating and exhilarating. It reminds us that the universe and the multiverse, if it exists, is far more complex than we can currently comprehend. But it also drives us to keep searching, to keep asking questions that push the boundaries of what we know. What's remarkable is how these forces, invisible and intangible, could hold the answers to some of the biggest questions in science. Are we alone in the cosmos, or are there other universes out there, each with its own version of dark matter and dark energy? Could these forces be the key to unlocking the secrets of the multiverse? As we continue to explore these mysteries, we're not just studying the universe, we're redefining our place within it. And in doing so, we're reminded that the cosmos is not just a place of stars and galaxies, but a tapestry of infinite possibilities, woven together by forces we're only beginning to understand. The conditions of our universe seem almost too perfect to be an accident. The laws of physics, the strength of gravity, the precise balance of forces, all of it appears exquisitely calibrated to allow stars, planets, and life itself to exist. But why? Why does the universe seem tailor-made for us? This is the heart of the Anthropic principle, a concept that challenges us to rethink the very nature of existence. At its core, the Anthropic principle suggests that the universe we observe must be compatible with the existence of observers, us. If it weren't, we wouldn't be here to ask the question in the first place. But this raises a deeper mystery. Is this fine-tuning a stroke of luck, or is there something more profound at work? Enter the multiverse. If our universe is just one among countless others, each with its own unique set of physical laws, then the fine-tuning we observe might not be so mysterious after all. In an infinite sea of universes, some will inevitably have the right conditions for life, while others will be barren or unstable. Our universe, in this view, isn't special, it's just one of the lucky ones. This idea offers a compelling explanation for why the constants of nature seem so finely tuned. In a multiverse, every possible combination of physical laws exists somewhere. We just happen to live in the universe where those laws allow galaxies, planets, and life to emerge, but this raises some profound questions. If there are infinite universes, does that mean there are infinite versions of us living out every possible variation of our lives? Could there be a universe where gravity is weaker or where the speed of light is slower? And if so, what does that mean for our understanding of reality? The Anthropic principle doesn't just challenge us to think about the conditions of our universe, it invites us to consider the possibility that our existence is just one thread in an infinite cosmic tapestry. This idea isn't without its critics. Some argue that the anthropic principle is a cop-out, a way to avoid grappling with the deeper question of why our universe is the way it is. Others point out that the multiverse theory is difficult, if not impossible, to test. After all, if other universes are completely disconnected from our own, how could we ever know they exist? Yet, despite these challenges, the anthropic principle remains a powerful tool for exploring the mysteries of the cosmos. It forces us to confront the question of whether our universe is unique or just one of many. What's fascinating is how this idea connects the scientific with the philosophical. The anthropic principle doesn't just ask how the universe works, it asks why. Why do the laws of physics allow for complexity and consciousness? Why does the universe seem so finely tuned for life? These questions don't have easy answers, but they remind us that science isn't just about discovering facts, it's about exploring the deeper meaning behind those facts. In a way, the anthropic principle is a bridge between the empirical and the existential, a way of thinking about the universe that's as much about curiosity as it is about calculation. As we ponder these ideas, we're not just studying the cosmos, we're reflecting on our place within it. The anthropic principle challenges us to see ourselves not as the center of the universe, but as part of a larger, more mysterious whole. It invites us to ask not just why we're here, but what it means to be here at all. And in doing so, it opens the door to a deeper understanding of the multiverse and ourselves. The cosmic microwave background, or CMB, is often called the afterglow of the Big Bang, a faint whisper of light that fills the universe, carrying secrets from its earliest moments. But what if this ancient glow could also reveal clues about other universes? For decades, scientists have studied the CMB not just to understand our own universe, but to search for hints of a multiverse. Amidst the uniform haze of this cosmic radiation, there are strange anomalies, subtle ripples and patterns that some researchers believe could be the fingerprints of other realities brushing up against our own. One of the most intriguing anomalies in the CMB is known as the cold spot, a region of space that's significantly cooler than its surroundings. At first glance, it might seem like a random quirk of nature, but some scientists propose a far more dramatic explanation, that this cold spot could be a bruise left by a collision with another universe. Imagine two soap bubbles floating in a bathtub. When they touch, they create a small dent or ripple at the point of contact. In the same way, if our universe collided with another, the energy from that encounter could leave a mark on the CMB, a kind of cosmic scar etched into the fabric of space-time. But interpreting these anomalies is no simple task. The CMB is incredibly faint, and the signals scientists are looking for are even fainter. It's like trying to hear a single note in a symphony of static. To make matters more complicated, there are other potential explanations for these anomalies. The cold spot, for instance, could simply be a vast void in space, a region where galaxies are unusually sparse, causing light to lose energy as it passes through. Or it could be the result of cosmic structures we don't yet fully understand. The challenge lies in distinguishing between these possibilities, separating the signal from the noise. Despite these hurdles, the search for multiverse evidence in the CMB has led to some fascinating theories. One idea is that if our universe is part of a multiverse, it might be surrounded by other universes like bubbles in a foam. Over time, these bubbles could collide or interact, leaving imprints on the CMB. These collisions wouldn't be violent crashes but gentle brushes, like two clouds passing through each other. The resulting patterns might be subtle, but they could hold the key to proving the existence of other universes. Of course, not everyone is convinced. Some scientists argue that these anomalies are simply statistical flukes, the kind of random variations you'd expect in any large dataset. Others caution that our current models of the CMB might be incomplete, and that what looks like evidence of a multiverse could simply be a gap in our understanding. It's a reminder that science is a process of constant questioning, of testing ideas against evidence and being willing to revise them when necessary. What makes this search so compelling is not just the possibility of finding other universes, but what it tells us about our own. By studying the CMB, we're not just looking for clues about the multiverse, we're piecing together the story of how our universe began and how it evolved. Every anomaly, every ripple is a piece of that puzzle, a chance to glimpse the deeper truths that lie hidden in the cosmos. As we continue to explore the CMB, we're not just searching for answers, we're learning how to ask better questions. What if the cold spot really is a sign of another universe? What would that mean for our understanding of reality? And if we do find evidence of a multiverse, how would it change the way we see ourselves and our place in the cosmos? These are the questions that drive us forward, pushing the boundaries of what we know and what we dare to imagine. The CMB is more than just a map of the universe, it's a window into the infinite, a reminder that the cosmos is always full of surprises. Black holes have long captivated our imagination, cosmic enigmas so dense that not even light can escape their gravitational pull. But what if these mysterious objects are more than just cosmic vacuum cleaners? What if they're gateways to other universes, portals to realities beyond our own? This idea, once the stuff of science fiction, has gained traction among some of the brightest minds in physics, including the legendary Stephen Hawking. In the final years of his life, Hawking proposed a theory that challenged everything we thought we knew about black holes and the multiverse. Picture a black hole as a cosmic whirlpool, a region of space where gravity is so intense that it warps the fabric of reality itself. According to classical physics, anything that crosses the event horizon, the point of no return, is lost forever, crushed into an infinitely dense singularity. But Hawking saw things differently. He suggested that black holes might not be the ultimate dead ends we once believed. Instead, they could be bridges to other universes, their immense gravitational power creating tunnels through the very fabric of space-time. These tunnels, known as wormholes, could connect our universe to others, offering a glimpse into the vast multiverse. But how does this work? One of Hawking's most groundbreaking ideas was that black holes aren't entirely black. Over time, they emit particles in the form of what we now call Hawking radiation. This process slowly causes black holes to lose mass and eventually evaporate. But here's the twist. Hawking argued that the information swallowed by a black hole isn't destroyed. It escapes, encoded in this radiation. This information could, in theory, emerge in another universe, creating a cosmic link between realities. Imagine a letter thrown into a black hole, its contents scrambled by the immense forces at play, only to reappear in a distant universe waiting to be decoded. It's a mind-bending concept that blurs the line between science and speculation. This idea builds on earlier theories about wormholes, hypothetical passages through space-time that could connect distant points in the universe, or even different universes altogether. Albert Einstein and Nathan Rosen first proposed the concept in the 1930s, suggesting that black holes might be connected to white holes, regions where matter and energy are expelled rather than absorbed. While white holes remain purely theoretical, the idea of black holes as gateways has sparked a wave of new research. Could these cosmic portals allow travel between universes or even between different points in time? The possibilities are as thrilling as they are perplexing. Of course, this raises a host of questions. If black holes are gateways, how could anything survive the journey? The extreme tidal forces near a black hole's event horizon would stretch and compress anything that ventured too close, a process physicists grimly call spaghettification. Yet, some theories suggest that certain types of black holes, known as rotating or Kerr black holes, might have stable wormholes at their cores. These could, in theory, provide a safe passage to another universe, though the energy required to create or stabilize such a tunnel remains far beyond our current capabilities. What makes these ideas so compelling is how they connect the known with the unknown. Black holes, once seen as the ultimate destroyers, might also be creators' gateways to new realities, new possibilities. They remind us that the universe is full of surprises, that even the most mysterious phenomena can hold the key to unlocking deeper truths. And while we may never step through a black hole ourselves, the very idea that they could connect us to other universes challenges us to think bigger, to imagine a cosmos that's far more interconnected than we ever realized. As we continue to explore these cosmic mysteries, we're reminded that the universe is not just a place of stars and galaxies, but a tapestry of infinite possibilities. Black holes, with their immense power and enigmatic nature, are a reminder that the cosmos is full of questions waiting to be answered, and that the journey to understand them is as thrilling as the answers themselves. What if everything we see, touch, and experience, every star, every galaxy, every moment in time, is nothing more than a projection, a kind of cosmic illusion? This is the essence of the holographic principle, a mind-bending idea that suggests our universe might be like a hologram, a three-dimensional image encoded on a two-dimensional surface. At first glance, it sounds like science fiction, but this principle has deep roots in the mathematics of black holes and string theory, and it could revolutionize how we think about the multiverse. The holographic principle emerged in the 1990s when physicists Gerard T. Hooft and Leonard Susskind proposed that all the information contained within a volume of space could be encoded on its boundary, much like how a hologram stores a 3D image on a 2D surface. Imagine writing a novel, but instead of filling hundreds of pages, you could capture the entire story on the cover. In the same way, the holographic principle suggests that the universe we perceive, with its galaxies, stars, and planets, might be a projection of information stored on a distant two-dimensional surface. It's a radical reimagining of reality, one that blurs the line between the physical and the informational. But how does this connect to the multiverse? If our universe is a holographic projection, could other universes exist as projections too? Some theorists suggest that higher dimensional realities might encode multiple universes, each one a unique projection from a shared boundary. Picture a vast cosmic library where every book represents a different universe, and the shelves themselves are the higher dimensional space from which these universes emerge. In this view, the multiverse isn't just a collection of separate worlds, it's a network of interconnected projections, each one a different expression of the same underlying reality. What's fascinating is how this idea ties into one of the most puzzling aspects of black holes. When matter falls into a black hole, what happens to the information it contains? According to the holographic principle, this information isn't lost, it's encoded on the black hole's event horizon, the boundary that marks the point of no return. This suggests that the event horizon acts like a cosmic hard drive, storing the information of everything that falls into the black hole. If this is true, could other universes be encoded on similar boundaries, their realities projected from higher dimensional surfaces? The implications are staggering. If the holographic principle is correct, it could mean that space and time, the very fabric of our reality, are emergent properties, illusions created by the way information is encoded and processed. It's a concept that challenges our deepest assumptions about existence, suggesting that the universe we perceive might be just one layer of a much deeper, more complex reality. And if other universes exist as projections from higher dimensions, it raises the question, what lies beyond the boundaries of our own reality? This idea doesn't just change how we think about the multiverse, it changes how we think about ourselves. If we're living in a holographic universe, what does that mean for our sense of identity, our understanding of consciousness, and our place in the cosmos? It's a question that bridges the gap between science and philosophy, inviting us to consider whether reality is as solid and unchanging as it seems, or whether it's something far more fluid and mysterious. As we explore these ideas, we're reminded that the universe is full of surprises, that even the most fundamental aspects of reality might be more complex than we ever imagined. The holographic principle doesn't just offer a new way to understand the multiverse, it invites us to rethink what it means to exist, to question the nature of reality itself. And in doing so, it opens the door to a deeper understanding of the cosmos, one where the boundaries between the known and the unknown are constantly shifting, where the universe we see might be just the beginning of a much larger, more extraordinary story. What if the universe we live in isn't real? What if everything we see, touch, and experience is nothing more than lines of code, a simulation running on some unimaginably advanced computer? This is the essence of the simulation hypothesis, a provocative idea that has sparked intense debate among scientists, philosophers, and even tech billionaires. While it might sound like the plot of a sci-fi blockbuster, this hypothesis raises profound questions about the nature of reality and how it might connect to the multiverse. The simulation hypothesis gained mainstream attention in the early 2000s when philosopher Nick Bostrom proposed a startling argument. If a civilization could one day create simulations indistinguishable from reality, and if that civilization chose to run countless such simulations, the odds are overwhelming that we're living in one of them. Think of it like this: if you were a character in a video game, how would you know you weren't real? For all you know, your entire world could be a digital creation designed by a programmer in a higher reality. It's a mind-bending concept that challenges our most basic assumptions about existence. But how does this idea connect to the multiverse? If our universe is a simulation, could there be other simulations running alongside it? Imagine a vast computer network, each node running its own unique simulation with its own set of rules and constants. In this scenario, the multiverse wouldn't just be a collection of physical universes, it could be a collection of digital ones, each one a self-contained reality with its own version of space, time, and even consciousness. This digital multiverse wouldn't require extra dimensions or parallel brains. It would exist purely in the realm of information, a network of virtual worlds running on some unimaginable hardware. The implications of this idea are staggering. If we're living in a simulation, it would mean that the laws of physics we take for granted, gravity, light, even time itself, are not fundamental truths but simply parameters programmed into the simulation. It would also mean that the universe could be far more malleable than we ever imagined. For instance, glitches in the code could explain some of the strange anomalies scientists have observed, like quantum entanglement or the peculiar behavior of particles at the subatomic level. And if the simulation were ever paused or altered, we might not even notice our reality could shift in an instant, like a scene in a video game being rewritten. Of course, not everyone is convinced. Critics argue that the simulation hypothesis is untestable, a philosophical thought experiment with no way to prove or disprove it. After all, if the simulation is perfect, how could we ever detect its boundaries or its creator? Some scientists have proposed experiments to test the idea, such as looking for patterns or limitations in the fabric of reality that might hint at a digital framework. Others suggest that the sheer complexity of simulating an entire universe makes the hypothesis implausible, even for an advanced civilization. But for many, the appeal of the simulation hypothesis lies not in its provability, but in the questions it forces us to ask. What is reality, and how do we know it's real? If we are living in a simulation, does that make our experiences any less meaningful? What's fascinating is how this hypothesis bridges the gap between science and philosophy. It challenges us to think about the nature of existence in a way that's both deeply personal and profoundly universal. Whether or not we're living in a simulation, the very idea forces us to confront the possibility that reality might be far stranger than we ever imagined. And if the multiverse exists as a network of simulations, it raises an even more intriguing question: who or what is running the program? Are we characters in someone else's story, or are we part of a cosmic experiment that even the creators don't fully understand? As we ponder these questions, we're reminded that the universe, real or simulated, is full of mysteries waiting to be unraveled. The simulation hypothesis doesn't just challenge our understanding of reality. It invites us to explore the boundaries of what we know and what we dare to imagine. Whether we're living in a simulation or not, one thing is certain: the quest to understand the cosmos is a journey that will always push us to think bigger, to see further, and to ask the questions that might just change everything. Mathematics has often been called the language of the universe, and when it comes to multiverse theories, it's the key that unlocks the door to higher dimensions and parallel realities. Imagine trying to describe a world you can't see, touch, or even fully comprehend. That's the challenge physicists face when exploring the multiverse, and it's where mathematics becomes indispensable. Through equations, models, and abstract concepts, mathematicians and physicists have crafted tools to visualize and understand realities that defy our everyday experience. One of the most fascinating mathematical constructs in multiverse theories is the Calabi-Yau manifold. Picture a shape so intricate and multidimensional that it exists in 6 or more dimensions, far beyond the 3 we're used to. These manifolds are like the hidden scaffolding of the universe, providing a framework for the extra dimensions predicted by string theory. Think of them as the geometric blueprints for how space could fold and twist in ways we can't directly observe. While our brains struggle to visualize these shapes, mathematicians describe them with precision, using equations that capture their beauty and complexity. It's like trying to describe a symphony using only sheet music. You might not hear the melody, but the notes tell you everything you need to know. But why are these manifolds so important? In string theory, particles aren't tiny dots but vibrating strings, and the way these strings move and interact depends on the geometry of the extra dimensions. Calabi-Yau manifolds provide the mathematical landscape where these vibrations occur, influencing everything from the behavior of particles to the laws of physics. Some physicists believe that different Calabi-Yau shapes correspond to different universes, each with its own unique set of physical laws. In this view, the multiverse isn't just a collection of random worlds, it's a vast, mathematically structured tapestry, where every universe is a unique pattern woven into the fabric of reality. What's remarkable about these mathematical models is how they bridge the gap between the abstract and the tangible. While we can't see or touch a Calabi-Yau manifold, the equations that describe them allow us to explore their properties and predict their effects on the physical world. It's a testament to the power of mathematics to reveal truths that lie beyond our sensory experience. And it's not just about solving equations, it's about uncovering the hidden order that underpins the cosmos. Yet, as elegant as these models are, they're not without challenges. The mathematics behind Calabi-Yau manifolds is incredibly complex, and finding solutions to these equations can take years of painstaking work. Even then, the results often raise more questions than answers. For example, string theory predicts an almost infinite number of possible Calabi-Yau shapes, each corresponding to a different universe. But which one describes our reality, and how do we choose between them? These questions highlight the delicate balance between mathematics and physics, between theory and observation. Despite these challenges, the role of mathematics in multiverse theories is undeniable. It's the lens through which we glimpse the deeper structure of reality, a tool that allows us to explore the unimaginable. From the intricate geometry of Calabi-Yau manifolds to the abstract equations of quantum mechanics, mathematics is the thread that ties together the many worlds of the multiverse. It's a reminder that even in the face of the unknown, we have the tools to explore, to question, and to imagine. And in doing so, we're not just uncovering the secrets of the cosmos, we're discovering the beauty of the language that describes it. The concept of the multiverse isn't just a scientific puzzle, it's a philosophical one. It forces us to confront some of the deepest questions about who we are, what reality is, and whether our choices truly matter. If there are infinite universes, each one a variation of our own, what does that mean for our sense of self? Are we unique, or are there countless versions of us out there, living different lives, making different choices? These aren't just abstract musings, they're questions that strike at the heart of what it means to be human. Consider the idea of identity. In a multiverse, every decision we make, no matter how small, could create a new universe where the opposite choice was made. In one reality, you might have chosen a different career, moved to a different city, or even taken a different path on your morning walk. In another, perhaps you never existed at all. This raises a profound question. If there are infinite versions of you, each shaped by different circumstances, which one is the real you? Philosophers like Derek Parfit have grappled with this idea, suggesting that personal identity might not be as fixed as we think. Instead, it could be more like a collection of possibilities, a mosaic of selves scattered across the multiverse. But what about free will? If every possible outcome exists in some universe, does that mean our choices are meaningless? Or does it mean that every choice we make is equally valid, creating a new path in the cosmic tapestry? The multiverse doesn't just challenge our understanding of reality, it challenges our understanding of agency. Are we the authors of our own stories, or are we simply playing out roles that have already been written in the infinite script of existence? Friedrich Nietzsche once wrote, "You must become who you are," but in a multiverse, who we are might be far more fluid than we ever imagined. The multiverse also raises existential questions about meaning and purpose. If there are infinite realities, each one a variation of our own, does that make our lives more meaningful or less? Some philosophers argue that the multiverse amplifies the significance of our choices, since every decision creates a new reality. Others suggest that it diminishes our sense of uniqueness, since every possible version of us already exists somewhere. Albert Camus, the existentialist philosopher, famously said, "Life is the sum of all your choices." But in a multiverse, those choices might not feel as personal or as consequential as we'd like to believe. And then there's the question of connection. If there are infinite versions of us, do we share anything in common with our counterparts in other universes? Are they truly us, or are they entirely separate beings who happen to share a similar starting point? This idea resonates with the work of philosopher David Lewis, who proposed that all possible worlds are equally real and that we exist in just one of them. In Lewis's view, our counterparts in other universes aren't just fictional, they're as real as we are, living out their own lives in their own realities. It's a thought that's both comforting and unsettling, suggesting that we're never truly alone, even in the vastness of the multiverse. What's remarkable about these philosophical questions is how timeless they are. From the ancient Greeks to modern thinkers, humanity has always wrestled with the nature of reality, identity, and free will. The multiverse doesn't just give us new ways to think about these questions, it gives us new ways to feel them. It invites us to see ourselves not as isolated individuals, but as part of an infinite web of possibilities, each one a thread in the grand tapestry of existence. As we explore these ideas, we're reminded that the multiverse isn't just a scientific theory, it's a mirror, reflecting our deepest hopes, fears, and curiosities back at us. It challenges us to rethink not just the universe but ourselves, and in doing so, it opens the door to a deeper understanding of what it means to exist in a cosmos that's always expanding, always evolving, and always full of surprises. The multiverse isn't just a scientific concept, it's a cultural phenomenon. Over the years, the idea of parallel worlds and alternate realities has seeped into our stories, shaping the way we think about possibility, identity, and the unknown. From the pages of science fiction novels to the dazzling screens of blockbuster films, multiverse theories have become a canvas for exploring some of humanity's deepest questions. And nowhere is this more evident than in the works of Philip K. Dick, a writer whose imagination seemed to stretch into dimensions far beyond our own. Philip K. Dick's novels like The Man in the High Castle and Ubik are steeped in the idea of multiple realities. In The Man in the High Castle, Dick imagines a world where the Axis powers won World War II, creating a chilling alternate history that feels uncomfortably close to our own. But it's not just about what happened, it's about what could have happened. Through his characters, Dick explores the fragility of reality, the idea that our world is just one thread in a vast tapestry of possibilities. His stories aren't just entertainment, they're philosophical explorations, asking us to consider how thin the line is between the real and the imagined. This fascination with alternate realities has only grown in the decades since Dick's work, finding a new home in the Marvel Cinematic Universe. Films like Doctor Strange in the Multiverse of Madness and Spider-Man, No Way Home have brought the multiverse to life in spectacular fashion, weaving complex narratives across parallel dimensions. In these stories, the multiverse isn't just a backdrop. It's a character in its own right, a source of both wonder and danger. It's a reminder that every choice we make could lead to an entirely different outcome, a theme that resonates deeply with audiences. Whether it's Peter Parker meeting alternate versions of himself or Doctor Strange confronting the consequences of tampering with reality, these films tap into our innate curiosity about what lies beyond the limits of our own world. But why are we so drawn to these stories? Perhaps it's because they reflect something fundamental about the human experience, our desire to explore, to imagine, to question. The multiverse offers a way to play out our deepest fears and hopes, to confront the what-ifs that linger in the back of our minds. What if I'd made a different choice? What if the world were different? These questions aren't just speculative, they're deeply personal, touching on themes of regret, possibility, and the search for meaning. The influence of multiverse theories isn't limited to literature and film. In art, too, we see echoes of these ideas. Surrealist painters like Salvador Dali and René Magritte have long been fascinated by the boundaries of reality, creating works that blur the line between the familiar and the fantastical. Their paintings feel like glimpses into alternate dimensions where the rules of physics and logic don't apply. Even in music, the multiverse has inspired artists to experiment with new sounds and structures, creating sonic landscapes that feel as vast and unpredictable as the cosmos itself. What's striking about this cultural impact is how it mirrors the evolution of multiverse theories in science. Just as physicists use equations and models to explore the unknown, artists use stories, images, and sounds to grapple with the same mysteries. Both are driven by a shared sense of curiosity, a desire to push beyond the limits of what we know and imagine what could be. And in doing so, they remind us that the multiverse isn't just a scientific concept, it's a reflection of our collective imagination, a way to make sense of a universe that's always been full of surprises. As we explore these stories, we're not just escaping into fantasy, we're engaging with ideas that challenge us to think bigger, to see further, to question the nature of reality itself. Whether it's through the pages of a novel, the frames of a film, or the strokes of a painting, the multiverse invites us to imagine a cosmos that's as rich and varied as the stories we tell about it. And in that sense, it's more than just a theory, it's a testament to the power of human creativity, a reminder that the universe is not just something we observe, but something we create one story at a time. What if every choice you make ripples across countless realities, shaping the lives of infinite versions of yourself? The multiverse isn't just a scientific theory, it's a profound challenge to how we think about ethics, responsibility, and the weight of our decisions. If there are infinite universes, each one a variation of our own, what does that mean for how we live our lives? Are we accountable only to ourselves, or do we owe something to the other versions of us out there, living different lives in different realities? These aren't just hypothetical questions, they're ethical dilemmas that force us to rethink the very foundations of morality. Let's start with the idea of responsibility. In a multiverse, every decision we make, whether it's choosing a career path, ending a relationship, or even something as mundane as what to eat for breakfast, could create a new universe where the opposite choice was made. Does that mean we should agonize over every decision, knowing the consequences could echo across realities? Or does it mean that our choices are ultimately meaningless, since every possible outcome already exists somewhere? Philosophers have long debated the concept of moral responsibility, but the multiverse adds a new layer of complexity. If there are infinite versions of us, each one shaped by different circumstances, who is truly accountable for the choices we make? This idea becomes even more complicated when we consider the concept of suffering. If every possible outcome exists in some universe, does that mean there are realities where suffering is far more prevalent or even universal? And if so, do we have a moral obligation to alleviate that suffering, even if we can't access those other realities? Some ethicists argue that the multiverse forces us to expand our moral circle, to consider not just the well-being of those in our own universe, but of all beings across all realities. It's a staggering thought, one that challenges us to think beyond the limits of our own experience. But what about the flip side? If there are infinite universes, each one a variation of our own, does that make our lives less meaningful or more? Some argue that the multiverse amplifies the significance of our choices, since every decision creates a new reality. Others suggest that it diminishes our sense of agency, since every possible version of us already exists somewhere. This tension between meaning and meaninglessness is at the heart of the multiverse's ethical implications. It forces us to ask, does the existence of other realities change how we value our own? These questions aren't just abstract, they have real-world implications. For example, how might the multiverse influence our approach to climate change? If there are universes where humanity has solved the climate crisis and others where we've failed, does that mean our efforts in this reality are less important? Or does it mean we have an even greater responsibility to act, knowing that our choices could shape the fate of countless realities? The multiverse doesn't just challenge our understanding of ethics, it challenges us to think about how our actions ripple across time, space, and even dimensions. At its core, the ethical questions raised by multiverse theories are about connection. They force us to consider how we relate not just to the people in our own lives, but to the infinite versions of ourselves and others who exist across the multiverse. It's a humbling thought, one that reminds us of the interconnectedness of all things. And while we may never know for sure whether other realities exist, the very possibility invites us to live with greater compassion, curiosity, and care, not just for ourselves, but for the infinite web of possibilities that make up the cosmos. As we grapple with these ideas, we're reminded that the multiverse isn't just a scientific concept, it's a mirror, reflecting our deepest hopes, fears, and responsibilities back at us. It challenges us to think bigger, to see further, and to act with greater intention. And in doing so, it opens the door to a deeper understanding of what it means to exist in a universe or a multiverse that's always expanding, always evolving, and always full of surprises. As we stand on the brink of a new era in cosmic exploration, the future of multiverse research is brimming with both excitement and uncertainty. Cutting-edge technologies and ambitious experiments are poised to push the boundaries of what we know, offering tantalizing glimpses into the possibility of other universes. One of the most eagerly anticipated tools in this quest is the James Webb Space Telescope, often hailed as the successor to Hubble. Unlike any telescope before it, Webb is designed to peer deeper into the cosmos than ever, capturing light from the earliest moments of the universe's formation. Its infrared capabilities allow it to see through cosmic dust, revealing galaxies and phenomena that have remained hidden until now. Could it also detect subtle anomalies, clues that point to the existence of other universes? The answer is far from clear, but the potential is undeniably thrilling. Beyond Webb, other groundbreaking projects are also in the works. Particle colliders like the Large Hadron Collider at CERN continue to smash particles together at unimaginable speeds, probing the fundamental laws of physics for signs of extra dimensions or hidden forces that might hint at a multiverse. Meanwhile, gravitational wave detectors such as LIGO and Virgo are listening for ripples in space-time that could reveal collisions between universes or other cosmic events that defy our current understanding. Each of these experiments is like a new chapter in a cosmic detective story, offering fresh opportunities to uncover the secrets of the multiverse, but the road ahead is far from straightforward. Multiverse research is a field fraught with challenges, not least of which is the difficulty of testing theories that exist beyond the reach of our current technology. How do you observe something that, by definition, might exist entirely outside our universe? Some scientists are exploring indirect methods, searching for subtle imprints in the cosmic microwave background or anomalies in the distribution of galaxies that could hint at interactions with other universes. Others are developing entirely new frameworks, blending mathematics, physics, and even philosophy to imagine what evidence of a multiverse might look like. What makes this moment so exhilarating is the sheer openness of the questions we're asking. For every theory about the multiverse, there are countless unknowns, each one a potential doorway to a deeper understanding of reality. The uncertainty isn't a limitation, it's an invitation to think bigger, to dream bigger. As we look to the future, one thing is certain: the journey to uncover the mysteries of the multiverse will be as transformative as the discoveries themselves. Whether we find definitive proof or simply new questions to ponder, the pursuit will forever change how we see the cosmos and our place within it. Artificial intelligence is no longer just the stuff of science fiction. It's become a powerful tool in the quest to understand the multiverse. Imagine sifting through mountains of cosmic data, searching for patterns so subtle they're invisible to the human eye. That's exactly what AI is doing in the field of multiverse research, acting as a cosmic detective that can process information faster and more accurately than any human ever could. From analyzing the faintest ripples in the cosmic microwave background to simulating the behavior of particles in higher dimensions, AI is revolutionizing how we explore the boundaries of reality. One of the most exciting applications of AI is its ability to uncover hidden patterns in vast datasets. Take the cosmic microwave background, for example, the ancient light left over from the Big Bang. This faint glow holds clues about the early universe, but its signals are incredibly complex and often buried in noise. AI algorithms trained on massive amounts of data can sift through this noise to identify subtle anomalies that might hint at the existence of other universes. These algorithms don't just look for what we already know. They're designed to spot the unexpected, the unusual, the signals that don't fit our current models. In this way, AI isn't just a tool, it's a partner in discovery, helping us see the cosmos in ways we never could before. But AI's role doesn't stop at data analysis. It's also being used to simulate multiverse scenarios, creating virtual models of how universes might form, evolve, and interact. These simulations allow scientists to test theories in ways that would be impossible in the real world. For instance, what happens when two universes collide? What kind of imprints would such an event leave on the fabric of space-time? By running countless simulations, AI can help us explore these questions, offering insights that might otherwise remain out of reach. It's like having a cosmic laboratory where we can experiment with the laws of physics, tweaking parameters and observing the results in real time. What makes this collaboration between AI and science so powerful is the way it amplifies human creativity. AI doesn't replace scientists, it empowers them, giving them the tools to ask bigger questions and explore deeper mysteries. It's a partnership that combines the best of both worlds, the intuition and imagination of the human mind with the precision and speed of machine intelligence. Together, they're pushing the boundaries of what we know, opening up new frontiers in our understanding of the cosmos. Yet, as with any tool, there are challenges. AI is only as good as the data it's trained on, and the complexity of multiverse theories means that even the most advanced algorithms have limits. There's also the question of interpretation. How do we make sense of the patterns AI uncovers? Are they evidence of other universes or just artifacts of the data? These are questions that scientists are still grappling with, but the potential is undeniable. By combining the power of AI with the ingenuity of human researchers, we're entering a new era of cosmic exploration, one where the mysteries of the multiverse might finally be within our grasp. As we look to the future, it's clear that AI will play an increasingly important role in multiverse studies. Whether it's uncovering hidden patterns, running intricate simulations, or helping us interpret the vastness of cosmic data, AI is a tool that's reshaping how we think about the universe and our place within it. And in this collaboration between human and machine, we're not just searching for answers, we're redefining what it means to explore the infinite. If the multiverse exists, teeming with countless universes, each governed by their own unique laws of physics, what does that mean for the search for life beyond our own world? Could life flourish in realities where gravity is weaker, where time flows backward, or where the very building blocks of matter are entirely different? These questions aren't just speculative, they're reshaping how we think about the possibility of extraterrestrial life, pushing the boundaries of what we consider life to be. Traditionally, the search for life beyond Earth has focused on finding conditions similar to our own planets within the Goldilocks zone of their stars, where liquid water can exist, and environments rich in the chemical building blocks we associate with biology. But if the multiverse is real, the rules of the game change entirely. In other universes, the constants we take for granted, like the strength of gravity or the charge of an electron, might be wildly different. Some universes could be so unstable that atoms never form, while others might have laws of physics that allow for entirely new forms of matter and energy. In such a cosmos, life might not look anything like what we recognize. It could be based on entirely different chemistry, or even exist in forms we can't yet imagine. This raises a tantalizing question. If life can exist in universes with different physical laws, how common might it be? Some scientists argue that in an infinite multiverse, life is inevitable, not just in universes like ours, but in those with entirely different conditions. Imagine a universe where the fundamental forces are so finely balanced that stars and planets never form, but where life emerges in swirling clouds of plasma or vast networks of energy. Or consider a reality where time loops back on itself, creating endless cycles of existence. In such universes, the concept of life might be as alien to us as we are to it. But how do we search for something so fundamentally different from what we know? The challenge is immense but not insurmountable. One approach is to look for signatures of universes beyond our own, subtle anomalies in the cosmic microwave background or gravitational waves that hint at interactions with other realities. Another is to rethink our assumptions about what life requires. Instead of focusing solely on carbon-based organisms or Earth-like conditions, scientists are exploring the possibility of life based on silicon, ammonia, or even entirely unknown elements. The multiverse forces us to expand our imagination, to consider that life might not be bound by the rules of our universe. What's fascinating is how this perspective shifts our understanding of our place in the cosmos. If life exists in other universes, does that make us more special or less? On one hand, it suggests that life might be a universal phenomenon, emerging wherever the conditions allow. On the other, it challenges our sense of uniqueness, reminding us that we might be just one of countless civilizations scattered across the multiverse. It's a humbling thought, but also an exhilarating one, inviting us to see ourselves as part of a much larger, more diverse cosmic community. As we continue to explore these ideas, we're not just searching for life, we're redefining what it means to be alive. The multiverse doesn't just expand the boundaries of the cosmos, it expands the boundaries of our imagination. It challenges us to think beyond the familiar, to embrace the possibility that life might exist in forms and places we can't yet conceive. And in doing so, it reminds us that the universe or universes are far stranger, far more wondrous, and far more interconnected than we ever imagined. So, as we peer into the cosmos, let's not just look for life as we know it, let's look for life as it could be in all its infinite variety. What if the key to time travel lies not within our own universe, but in the vast expanse of the multiverse? The idea of traveling through time has fascinated humanity for centuries, but when you introduce the concept of parallel realities, the possibilities and paradoxes become even more intriguing. Imagine stepping into a different timeline where the past, present, and future are fluid, and every decision creates a new branch of reality. This isn't just the stuff of science fiction, it's a theory that some physicists take seriously. In a multiverse, time travel might not just be possible, it could be inevitable. One of the most compelling theories linking the multiverse to time travel comes from the idea of alternate timelines. In these scenarios, every choice you make creates a new universe. For example, if you decide to take a different route to work today, that decision could spawn a parallel reality where the outcome of your day, or even your life, is entirely different. Now imagine if you could somehow jump between these timelines. In one universe, you might witness the consequences of a choice you didn't make in your own reality. In another, you could find yourself in a world where history took a completely different turn. This is the essence of multiverse-based time travel. Not moving through time in a linear sense, but navigating the branching paths of infinite realities. But here's where things get tricky. Time travel in the multiverse doesn't just open up possibilities, it also creates paradoxes. Take the classic grandfather paradox, where a time traveler goes back in time and accidentally prevents their own birth. In a single universe model, this creates a logical contradiction. But in a multiverse, the paradox might resolve itself. If you travel back in time and change something, you're not altering your own timeline, you're creating a new one. The original universe where you were born still exists, but now there's a parallel reality where you were never born. It's a mind-bending concept, but it offers a way to sidestep the paradoxes that plague traditional time travel theories. Science fiction has long explored these ideas, often with dazzling creativity. Take the film Interstellar, for example. While it doesn't explicitly involve the multiverse, it plays with the idea of time as a dimension that can be manipulated. In one scene, the protagonist communicates with his daughter across different points in time, hinting at the fluidity of reality. Then there's The Flash, a TV series where the titular hero discovers that his time-traveling exploits have created Flashpoint, an alternate timeline with devastating consequences. These stories aren't just entertainment, they're thought experiments, inviting us to consider the ethical and existential implications of tampering with time and reality. But what about the science? Could multiverse-based time travel ever be more than just a plot device? Some physicists speculate that wormholes, hypothetical tunnels through space-time, could serve as gateways between universes. If these wormholes exist, they might allow for shortcuts not just through space, but through time as well. Imagine stepping into a wormhole in one universe and emerging in another, where time flows at a different rate or even in a different direction. It's a tantalizing idea, though one that remains firmly in the realm of theory for now. The multiverse doesn't just expand our understanding of time travel, it redefines it. Instead of a single timeline, we're faced with an infinite web of possibilities, each one a unique expression of reality. This raises profound questions about free will, destiny, and the nature of existence itself. Are we bound by the choices we make, or do we exist in every possible version of ourselves, living out every conceivable outcome? And if we could travel between these realities, would we even recognize ourselves in the process? As we explore these questions, we're reminded that the multiverse isn't just a scientific concept, it's a lens through which we can examine the deepest mysteries of time, identity, and possibility. Whether or not multiverse-based time travel ever becomes a reality, the very idea challenges us to think bigger, to imagine a cosmos where the past, present, and future are not fixed points, but infinite horizons waiting to be explored. What if the multiverse isn't just a physical construct, but a mental one as well? What if our consciousness, the very essence of who we are, isn't confined to a single reality, but extends across multiple universes? This idea, while deeply speculative, has captured the imagination of scientists and philosophers alike, offering a radical new way to think about the mind, the self, and the nature of existence itself. At its core, the connection between the multiverse and consciousness challenges us to consider whether our awareness might be more expansive and more mysterious than we ever imagined. One of the most intriguing theories in this space comes from the intersection of quantum mechanics and neuroscience. Some researchers propose that consciousness isn't just a byproduct of the brain, but a fundamental feature of the universe woven into the fabric of reality. In this view, every decision we make, every thought, every moment of awareness could create a branching path of realities, each one a unique expression of our consciousness. Imagine your mind as a river flowing through the landscape of the multiverse, splitting into countless tributaries with every choice you make. In one reality, you might choose coffee over tea, while in another, the opposite is true. But here's the twist: your consciousness could, in theory, extend across all these realities, experiencing every possible outcome simultaneously. It's a concept that blurs the line between the self and the cosmos, suggesting that our minds might be far more interconnected with the universe than we realize. This idea resonates with the work of physicist Roger Penrose and anesthesiologist Stuart Hameroff, who propose that consciousness arises from quantum processes within the brain. According to their theory, known as ORCH, or orchestrated objective reduction, these quantum processes could link our minds to the multiverse, allowing our awareness to exist across multiple realities. While this theory remains controversial, it opens up fascinating possibilities. Could our consciousness be a kind of quantum phenomenon, flickering between universes like a flame dancing between candles? And if so, what does that mean for our sense of self? Are we truly singular beings, or are we fragmented across countless realities, each version of us experiencing a different thread of existence? The implications of this idea are profound, especially when it comes to our understanding of identity. If our consciousness extends across multiple realities, does that mean there's no single you? Instead, you might be a collection of selves scattered across the multiverse, each one shaped by different choices and circumstances. Philosophers like David Chalmers have explored this idea, suggesting that consciousness might be a universal phenomenon, not limited to individual brains but spread across the cosmos. In this view, the multiverse isn't just a collection of physical worlds, it's a tapestry of minds, each one a unique expression of awareness. But what about the practical implications? If our consciousness is connected to the multiverse, could we ever become aware of these other realities? Some theories suggest that dreams, déjà vu, or even moments of intuition might be glimpses into alternate versions of ourselves, fleeting connections to the broader web of existence. Think of it like tuning a radio. Most of the time, we're locked onto one frequency, our current reality, but every now and then we catch a faint signal from another station, another universe. These moments might be rare and fleeting, but they hint at a deeper connection, a way in which our minds might be attuned to the infinite possibilities of the multiverse. What's truly fascinating about this idea is how it bridges the gap between science and spirituality. For centuries, mystics and philosophers have speculated about the nature of consciousness, suggesting that it transcends the physical world. The multiverse offers a modern framework for these ancient ideas, suggesting that our awareness might not be bound by the limits of space and time. It's a concept that invites us to think of ourselves not as isolated individuals, but as part of a vast, interconnected network of minds, each one a unique expression of the cosmos. As we explore these ideas, we're reminded that the multiverse isn't just a scientific theory, it's a mirror, reflecting our deepest questions about who we are and what it means to exist. It challenges us to see consciousness not as a solitary flame, but as a constellation of lights, each one shining in its own reality, yet connected to the whole. And in doing so, it invites us to embrace the mystery, to see ourselves not as separate from the universe, but as an integral part of its infinite complexity. Whether or not these theories hold true, they remind us that the journey to understand the cosmos is also a journey to understand ourselves, and that, in the end, the two might be one and the same. The idea of a multiverse, a cosmos filled with countless universes, has long captivated scientists and philosophers. But what does it mean for the world's religions? For centuries, faith traditions have offered their own explanations for the origins and nature of existence. Now, as science explores the possibility of multiple worlds, a fascinating dialogue is emerging between spirituality and the multiverse. How do religions interpret the concept of infinite realities? Does it challenge their teachings, or does it offer new ways to understand the divine? Let's explore how the multiverse intersects with faith, and how this conversation is shaping our understanding of both science and spirituality. In Hinduism, the concept of multiple worlds is not only accepted but celebrated. Ancient texts like the Puranas describe an infinite number of universes or lokas, each governed by its own laws and deities. These universes are said to cycle through creation and destruction, endlessly rising and dissolving like waves in a cosmic ocean. For Hindus, the multiverse is not a scientific hypothesis, it's a spiritual reality, a reflection of the infinite creativity of the divine. The idea of countless worlds aligns seamlessly with the Hindu belief in Brahman, the ultimate reality that transcends all forms and boundaries. In this view, the multiverse doesn't challenge faith, it deepens it, offering a glimpse into the boundless nature of existence. Christianity, on the other hand, has a more complex relationship with the multiverse. Traditionally, Christian theology has focused on a single creation story, with humanity at the center of God's plan. But some theologians argue that the multiverse could align with Christian teachings about God's infinite power and creativity. If God is omnipotent, why limit creation to just one universe? Theologians like Thomas Aquinas have pondered this question, suggesting that God's ability to create is not constrained by human understanding. For them, the multiverse could be a testament to divine majesty, a way to express the limitless nature of God's love and imagination. At the same time, others worry that the multiverse might diminish humanity's unique role in creation, raising questions about the purpose of life and the nature of salvation. Buddhism offers yet another perspective. In Buddhist cosmology, the universe is vast and cyclical, with countless worlds arising and passing away in an endless flow. The multiverse fits naturally into this framework, echoing the Buddhist emphasis on impermanence and interconnectedness. For Buddhists, the idea of multiple realities isn't about proving or disproving the existence of God, it's about understanding the nature of existence itself. The multiverse becomes a metaphor for the infinite possibilities of karma, where every action creates ripples that shape future realities. In this way, the multiverse doesn't just coexist with Buddhist teachings, it enriches them, offering a modern lens through which to explore ancient truths. Islam, too, has engaged with the idea of multiple worlds. The Quran speaks of God as the creator of the heavens and the earth and all that is between them, a phrase that some scholars interpret as a reference to multiple universes. Islamic thinkers like Al-Farabi and Ibn Arabi have explored the concept of layered realities, where each universe reflects a different aspect of divine wisdom. For them, the multiverse is not a challenge to faith but an invitation to marvel at the complexity of God's creation. At the same time, some Muslims caution against overemphasizing speculative ideas, reminding believers to focus on the core teachings of the Quran and the Prophet Muhammad. This intersection of multiverse theories and religious beliefs raises profound questions about the relationship between science and spirituality. Are they competing narratives, or can they coexist in a shared quest for understanding? Some see the multiverse as a bridge, offering new ways to explore age-old questions about the nature of existence, the purpose of life, and the role of humanity in the cosmos. Others worry that the multiverse might undermine faith, reducing the divine to a set of physical laws. But perhaps the most exciting possibility is that the multiverse could spark a new kind of dialogue, one that honors both the rigor of science and the depth of spiritual wisdom. As we journey through these ideas, we're reminded that the multiverse isn't just a scientific concept, it's a mirror, reflecting our deepest questions about who we are and why we're here. Whether through the lens of faith or the tools of science, the multiverse invites us to explore the infinite, to marvel at the complexity of existence, and to seek meaning in the vast, interconnected web of reality. And in that search, we might just find that science and spirituality are not so different after all. Both are ways of reaching toward the unknown, of seeking truth in a cosmos that's always full of surprises. What is real? It's a question that has puzzled philosophers, scientists, and dreamers for centuries. But when we introduce the concept of the multiverse, this question takes on a whole new dimension. If there are infinite universes, each with its own set of physical laws and possibilities, does that mean reality itself is fluid? Are the rules we live by absolute, or are they just one set among countless others? These aren't just abstract musings, they're questions that challenge the very foundation of how we perceive existence. The multiverse doesn't just expand our understanding of the cosmos, it forces us to confront the nature of reality itself. Let's start with a thought experiment. Imagine you're standing in a room with two doors. Behind one door is a world where time flows backward, behind the other, a universe where gravity is so weak that you could leap tall buildings in a single bound. Which one is the real world? In a multiverse, both could be equally real, each one a valid expression of existence. This raises a profound question. Is reality something fixed and objective, or is it subjective, shaped by the unique conditions of each universe? Philosophers have long debated whether reality exists independently of our perception or is constructed by our minds. The multiverse adds a fascinating twist to this debate, suggesting that reality might be both, a vast objective tapestry of universes, each one experienced subjectively by its inhabitants. This idea becomes even more intriguing when we consider how the multiverse might blur the line between the objective and the subjective. Take, for example, the concept of quantum superposition, where particles exist in multiple states until they're observed. In the many worlds interpretation of quantum mechanics, every possible outcome of an event actually happens, branching off into separate universes. This means that what we perceive as reality, the outcome we observe, is just one slice of a much larger, more complex whole. In this view, reality isn't a single, unchanging truth. It's a mosaic of possibilities, each one as real as the next. But how does this affect our understanding of truth? If there are infinite realities, each one equally valid, does that mean there's no such thing as objective truth? Some argue that the multiverse suggests a kind of cosmic relativism, where truth is context-dependent, shaped by the unique conditions of each universe. Others counter that while the laws of physics might vary across universes, there could still be fundamental truths that apply to all of them, like the existence of space, time, or consciousness. It's a debate that pushes us to think beyond the limits of our own experience, to imagine a cosmos where truth is as vast and varied as the universes themselves. Now let's dive into another thought experiment. Imagine a universe where the speed of light is 10 times faster than in our own. In this world, stars might burn brighter and die younger, civilizations might rise and fall in the blink of an eye, and the night sky could be filled with colors we've never seen. Is this universe less real than ours, or is it simply a different expression of reality, governed by its own unique laws? The multiverse challenges us to expand our definition of reality, to see it not as a single, monolithic truth, but as a spectrum of possibilities, each one a valid and vibrant expression of existence. This raises an even deeper question. If reality is so fluid, what does that mean for us? Are we the architects of our own reality, shaping it through our choices and perceptions? Or are we simply passengers carried along by the currents of a cosmos that's infinitely larger and stranger than we can imagine? The multiverse doesn't just challenge our understanding of the universe, it challenges our understanding of ourselves. It invites us to see reality not as a fixed backdrop, but as a dynamic, ever-changing stage where every choice we make, every observation we record, adds a new thread to the infinite tapestry of existence. As we grapple with these ideas, we're reminded that the multiverse isn't just a scientific theory, it's a philosophical journey. It forces us to confront the nature of reality, to question what we know, and to imagine what could be. Whether reality is objective or subjective, fixed or fluid, one thing is certain. The multiverse has forever changed how we think about the cosmos and our place within it. And as we continue to explore these mysteries, we're reminded that the search for truth is not just about finding answers, it's about embracing the infinite possibilities of existence. The multiverse is a concept that stretches the boundaries of imagination, pushing us to confront the limits of human understanding. As we've journeyed through ancient myths, quantum mechanics, and cosmic inflation, one thing becomes clear. The sheer scale and complexity of the multiverse challenge everything we think we know about reality. But here's the question, Are our minds even equipped to grasp such vast and intricate ideas? The truth is, our brains evolved to navigate a world of tangible objects, predictable patterns, and linear timelines, not infinite universes with alternate laws of physics. This isn't just a scientific hurdle, it's a deeply human one. Consider this: our brains are wired to process information in familiar frameworks. We think in terms of cause and effect, space and time, beginnings and endings. But the multiverse defies these categories. How do you wrap your mind around a cosmos where every decision spawns a new universe, where time might loop or branch, and where the very fabric of reality could be a hologram? These ideas don't just challenge our intellect, they challenge our intuition, the way we instinctively make sense of the world. It's like trying to explain color to someone who's never seen light. The language we use to describe reality might not even apply. This isn't just a limitation of knowledge, it's a limitation of perception. Think of it like this: imagine a fish swimming in the ocean. It has no concept of what lies beyond the water, no way to imagine the sky, the stars, or the vastness of space. In the same way, our understanding of the multiverse might be constrained by the water of our own reality. We can theorize, model, and speculate, but can we ever truly comprehend what lies beyond the boundaries of our universe? It's a humbling thought, one that reminds us how small we are in the grand scheme of things. But humility isn't a weakness, it's a strength. Acknowledging the limits of our understanding is the first step toward deeper exploration. It's what drives scientists to ask better questions, to develop new tools, and to push the boundaries of what's possible. After all, every great leap in human knowledge began with a moment of humility, with the recognition that there's always more to learn. The multiverse doesn't just challenge us to think bigger, it challenges us to think differently, to embrace the unknown with curiosity and wonder. At the same time, this journey isn't just about science, it's about what it means to be human. The multiverse invites us to reflect on our place in the cosmos, to consider how we fit into a reality that might be far stranger and more interconnected than we ever imagined. It's a reminder that our quest for knowledge isn't just about finding answers, it's about asking questions that push us to grow, to evolve, and to see the world in new ways. So, as we grapple with the mysteries of the multiverse, let's not be discouraged by the limits of our understanding. Instead, let's see them as an invitation, a call to explore, to wonder, and to marvel at the infinite possibilities of existence. The multiverse isn't just a scientific concept, it's a mirror reflecting our deepest questions about who we are and what we're capable of. And in that reflection, we might just find the courage to keep searching, even when the answers seem out of reach. At the heart of every scientific revolution lies a question: how do we know what we know? Multiverse theories, with their mind-bending implications, aren't just challenging our understanding of the cosmos, they're pushing the boundaries of the philosophy of science itself. For centuries, science has relied on empirical evidence, observable, measurable data that can be tested and repeated. But when it comes to the multiverse, the rules of the game shift dramatically. How do you gather evidence for something that, by definition, might exist entirely outside our own universe? This tension between what we can observe and what we can only imagine is at the core of the multiverse debate, and it's forcing us to rethink what it means to do science. Think of it like this: if you're a detective, your job is to solve a crime by gathering clues, interviewing witnesses, and piecing together a story that fits the facts. But what if the crime took place in a world you can't access, where the laws of physics are completely different? That's the challenge scientists face when exploring the multiverse. Theories like string theory and cosmic inflation offer elegant mathematical frameworks, but they often rely on phenomena that are impossible to observe directly. Does that make them less scientific, or does it simply mean we need to expand our definition of what science can be? this question has sparked a lively debate among philosophers of science. Some argue that a theory must be falsifiable, meaning there must be a way to prove it wrong to be considered scientific. By this standard, multiverse theories are on shaky ground, since many of their predictions lie beyond our ability to test. Others counter that science has always been about pushing boundaries, about exploring ideas that stretch the limits of what we can observe. After all, no one has ever seen an atom, yet the atomic theory is the foundation of modern physics. The multiverse, they argue, is no different, a bold idea that challenges us to think bigger, even if we can't yet see the whole picture. What's fascinating about this debate is how it highlights the importance of curiosity and open-mindedness in scientific inquiry. The multiverse doesn't just challenge our tools and methods, it challenges our mindset. It asks us to embrace uncertainty, to be comfortable with questions that might not have answers, and to see speculation not as a weakness but as a strength. In this way, the multiverse isn't just a scientific concept, it's a call to action, reminding us that the pursuit of knowledge is as much about imagination as it is about evidence. At the same time, the multiverse forces us to confront the limits of human understanding. Our brains evolved to navigate a world of 3 dimensions and linear time, not infinite universes with alternate laws of physics. This isn't just a scientific challenge, it's a deeply human one. How do we make sense of a cosmos that might be stranger and more complex than we can ever fully comprehend? The answer lies not in abandoning our curiosity, but in embracing it, in recognizing that the journey to understand the universe is as important as the destination. What's remarkable about the multiverse is how it brings together science and philosophy, showing us that the two are not so different after all. Both are ways of asking big questions, of seeking truth in a world that's always full of surprises. And both remind us that the search for knowledge is not just about finding answers, it's about learning to ask better questions. Whether or not the multiverse exists, it has already changed the way we think about science, challenging us to see the cosmos not as a static collection of facts, but as a dynamic, ever-evolving mystery. As we explore these ideas, we're reminded that the philosophy of science is not just an academic exercise. It's a way of seeing the world. It's about balancing skepticism with wonder, evidence with imagination, and humility with ambition. And in this balance, we find not just a deeper understanding of the multiverse, but a deeper understanding of ourselves. The multiverse invites us to see science not as a set of answers, but as a journey that's as vast, as complex, and as endlessly fascinating as the cosmos itself. Imagine a future where humanity's understanding of the cosmos has expanded far beyond the boundaries of our own universe. A future where the multiverse isn't just a theory, but a reality we've begun to explore. What might that mean for us as a species? How could the idea of infinite worlds reshape our technology, our discoveries, and even our way of thinking? This isn't just science fiction, it's a future that multiverse theories are already beginning to inspire, one filled with possibilities that could redefine what it means to be human. One of the most exciting prospects lies in the realm of technology. If the multiverse exists, it could open the door to entirely new forms of energy, computing, and even transportation. Picture this: what if we could harness the power of parallel universes to create energy sources that seem almost magical by today's standards? Quantum computers, which already rely on the strange behavior of particles at the subatomic level, might one day tap into the computational power of multiple realities, solving problems that are currently beyond our reach. And what about travel? If wormholes or other cosmic shortcuts exist, they could revolutionize how we explore not just our own universe, but others as well. These ideas are still in their infancy, but they hint at a future where the multiverse isn't just a concept, it's a tool, a resource, and a frontier waiting to be explored. But the impact of multiverse theories goes beyond technology. They could also transform how we think about our place in the cosmos. For centuries, humanity has grappled with questions of purpose and meaning, often seeing ourselves as the center of the universe. The multiverse challenges that view, suggesting that we might be just one thread in an infinite tapestry of realities. This isn't a cause for despair, it's an invitation to think bigger. If there are countless versions of us out there, each living out different lives and making different choices, what does that mean for our own sense of identity and purpose? It's a question that could inspire new ways of thinking about ethics, philosophy, and even art, as we explore what it means to exist in a cosmos that's infinitely diverse. What's truly remarkable about these ideas is the sense of wonder they inspire. The multiverse isn't just a scientific theory, it's a story, one that invites us to dream of possibilities we've never considered. It's a reminder that the universe or universes are far stranger and more wondrous than we ever imagined. And in that sense, the multiverse isn't just shaping the future of humanity, it's shaping the future of curiosity itself. It's encouraging us to ask questions we might never have thought to ask, to imagine worlds we might never have dared to imagine, and to see the cosmos not as a static backdrop, but as a dynamic, ever-changing stage. And then there's the question of collaboration. Exploring the multiverse isn't something humanity can do alone. It will require unprecedented cooperation across borders, disciplines, and even generations. Scientists, philosophers, engineers, and artists will all have a role to play, each bringing their unique perspective to the table. This collaboration could lead to breakthroughs not just in science, but in how we relate to one another as a global community. The multiverse could become a unifying idea, a shared goal that inspires us to work together in ways we never have before. Of course, the journey ahead won't be easy. The multiverse presents challenges that will test the limits of our knowledge and imagination. But that's what makes it so exciting. Every question we answer will lead to new questions, every discovery will open up new frontiers, and every step forward will bring us closer to understanding the infinite possibilities of existence. It's a journey that will require not just intelligence, but the courage to embrace the unknown, to challenge our assumptions, and to see the cosmos not as something to be conquered, but as something to be explored with humility and wonder. As we look to the future, one thing is clear: the multiverse isn't just a scientific idea, it's a vision of what humanity could become. It's a reminder that the quest for knowledge is never ending, that the universe is always full of surprises, and that the greatest discoveries are often the ones we haven't even imagined yet. Whether or not we ever find definitive proof of other universes, the very act of searching will change us, pushing us to think bigger, dream deeper, and see the cosmos and ourselves in a whole new light. And in that light, the future of humanity shines brighter than ever. The idea of a multiverse, a cosmos teeming with infinite realities, doesn't just challenge our understanding of the universe. It forces us to confront some of the most profound questions about existence itself. If there are countless worlds, each one a variation of our own, what does that mean for the meaning of life? Are we more significant because we're part of an infinite tapestry, or less significant because we're just one thread among countless others? These questions aren't just philosophical musings, they are at the heart of humanity's timeless search for purpose. For centuries, thinkers have grappled with the question of meaning, often framing it within the context of a single, finite universe. But the multiverse shifts the goalposts entirely. Take the existentialist philosopher Jean-Paul Sartre, who famously declared that existence precedes essence, meaning that we create our own purpose through our choices. In a multiverse where every decision spawns a new reality, this idea takes on a whole new dimension. If every possible version of us exists somewhere, does that make our choices more meaningful? or does it dilute their significance, spreading them thin across infinite possibilities? On one hand, the multiverse could amplify our sense of purpose. Imagine that every action you take, no matter how small, creates ripples across countless realities. In one universe, your kindness might inspire a stranger to change their life. In another, your courage might spark a revolution. This interconnected web of choices suggests that our lives are far more impactful than we realize, woven into the very fabric of existence. As the poet Maya Angelou once said, "We are more alike, my friends, than we are unalike." In a multiverse, this sentiment takes on cosmic proportions, reminding us that our actions resonate far beyond the confines of our own reality. But there's another side to the coin. If there are infinite versions of us, each living out different lives, does that make any one of us less unique? The philosopher Albert Camus wrestled with the absurdity of existence, arguing that life's meaning is found not in some grand cosmic plan, but in the struggle itself. In a multiverse, this struggle might feel even more absurd, as every victory and defeat is mirrored endlessly across realities. Yet, Camus also believed that the very act of searching for meaning is what gives life its richness. Perhaps in a cosmos of infinite possibilities, the journey is the destination, and the search for purpose is itself a form of meaning. What's fascinating is how the multiverse bridges the gap between the personal and the universal. It invites us to see ourselves not as isolated individuals, but as part of a vast, interconnected whole. The physicist Carl Sagan once wrote, "We are a way for the cosmos to know itself." In a multiverse, this idea becomes even more profound. Each of us, in our own reality, is a unique expression of the cosmos, a way for the infinite to experience itself in all its diversity. This perspective doesn't diminish our significance, it elevates it, reminding us that we are both finite and infinite, both small and vast. At the same time, the multiverse challenges us to rethink our relationship with the unknown. For some, the idea of infinite realities is comforting, offering endless possibilities for growth, exploration, and connection. For others, it's unsettling, suggesting that our lives might be just one of countless iterations, each one as fleeting and fragile as the next. This tension between comfort and unease is at the heart of the human experience, a reminder that meaning isn't something we find. It's something we create through our choices, our relationships, and our willingness to embrace the mysteries of existence. As we ponder these ideas, we're reminded that the multiverse isn't just a scientific concept, it's a mirror, reflecting our deepest hopes, fears, and questions back at us. Whether it makes life more or less significant is less important than the fact that it challenges us to think bigger, to see ourselves not as isolated beings, but as part of a cosmos that's infinitely complex and endlessly beautiful. And in that challenge, we might just find the meaning we've been searching for all along. As we journey through the vast and intricate landscape of multiverse theories, one thing becomes abundantly clear: the unknown far outweighs what we know. Despite the incredible strides we've made in physics, cosmology, and philosophy, the multiverse remains one of the most tantalizing mysteries of our time. It's a concept that doesn't just push the boundaries of science, it challenges the very limits of human curiosity. What lies beyond the edge of our universe? Are there other realities out there, hidden from view, each one a new frontier waiting to be explored? These questions don't just baffle scientists, they captivate anyone who's ever looked up at the night sky and wondered what's out there. The allure of the multiverse lies not in its answers, but in its questions. For every theory we propose, a dozen more mysteries emerge. Take the concept of cosmic inflation, for example. While it beautifully explains the uniformity of our universe, it also suggests that our reality might be just one bubble in an infinite cosmic foam. But if that's true, what triggers inflation in the first place? And why does it stop in some regions, allowing universes like ours to form, while continuing indefinitely in others? These are puzzles that even the brightest minds in physics are still grappling with, and they remind us that the multiverse isn't just a scientific idea. It's a puzzle box filled with layers of complexity waiting to be unlocked. Then there's the mystery of dark matter and dark energy, the invisible forces that make up the vast majority of our universe. While we've made progress in understanding their effects, we still don't know what they are. Could these elusive substances hold the key to connecting our universe with others? Some theories suggest that dark matter could form bridges between universes, while dark energy might be responsible for creating new ones. But without direct evidence, these ideas remain in the realm of speculation, tantalizing hints of a deeper truth that we've yet to uncover. What's perhaps most fascinating about these unsolved mysteries is how they inspire us. The multiverse isn't just a scientific challenge, it's a call to adventure. It invites us to explore the unknown, to ask questions that might not have answers, and to embrace the possibility that the cosmos is far stranger than we ever imagined. This sense of wonder isn't just for scientists, it's for all of us. Whether you're a physicist, a philosopher, or simply someone who loves to ponder the big questions, the multiverse offers a playground for the imagination, a space where curiosity knows no bounds. And yet, for all its mysteries, the multiverse also offers a profound sense of connection. It reminds us that we're part of something much larger than ourselves, a cosmos that's infinitely complex and endlessly beautiful. Even as we grapple with the unknown, we're reminded that the search for answers is itself a form of meaning. The multiverse doesn't just challenge us to think bigger, it challenges us to see ourselves as explorers, charting a course through the infinite possibilities of existence. As we continue to explore these ideas, we're reminded that the multiverse isn't just a scientific concept, it's a story. It's a story about curiosity, about the joy of discovery, and about the endless quest to understand the cosmos. And in that story, we're not just passive observers, we're active participants, shaping the narrative with every question we ask and every mystery we uncover. The multiverse may be full of unknowns, but that's what makes it so exciting. It's a reminder that the universe or universes are always full of surprises, and that the journey to understand them is just as important as the destination. From the ancient myths of infinite worlds to the cutting-edge theories of modern physics, our journey through the untold histories of the multiverse has been nothing short of extraordinary. We've traced the evolution of an idea that began as a whisper in the minds of philosophers and visionaries, a whisper that has grown into a roar, echoing across the centuries and reshaping how we see the cosmos. What's remarkable is how these ancient ideas, once dismissed as mere flights of imagination, now resonate so deeply with the discoveries of science. The Hindu lokas, the infinite worlds of Democritus, and the speculative musings of medieval theologians all point to a truth we're only beginning to grasp, that the universe or universes are far more vast and mysterious than we ever imagined. This connection between the ancient and the modern isn't just a coincidence, it's a testament to humanity's unyielding curiosity. For thousands of years, we've looked to the stars and wondered, are we alone? What lies beyond the horizon of our understanding? Today, those questions have taken on new dimensions as theories like cosmic inflation, string theory, and the many worlds interpretation challenge us to think bigger, to imagine a cosmos where every possibility exists somewhere. The multiverse isn't just a scientific concept, it's a bridge between the past and the future, a way to honor the wisdom of our ancestors while pushing the boundaries of what we know. But what does all of this mean for us? The implications of multiverse theories go far beyond physics. They touch the very core of who we are. If there are infinite versions of reality, what does that say about identity? Are we unique, or are we just one thread in an infinite tapestry of selves? And if the universe is a hologram, a simulation, or a cosmic symphony of vibrating strings, what does that mean for our understanding of existence? These questions don't just challenge our minds, they challenge our hearts, inviting us to see ourselves not as isolated beings, but as part of something vast, interconnected, and endlessly beautiful. As we stand on the edge of this cosmic frontier, it's worth reflecting on the words of Carl Sagan, who once said, "Somewhere, something incredible is waiting to be known." The multiverse is that incredible something, a mystery that beckons us to explore, to question, and to dream. It's a reminder that the universe isn't just out there, it's within us, a source of wonder and inspiration that has driven humanity forward for millennia. And while we may never have all the answers, the journey itself is what makes life meaningful. So, what do you think? Do you believe in the multiverse, or do you see it as a fascinating thought experiment? How does the idea of infinite realities change the way you see yourself and the world around you? Share your thoughts in the comments below. I'd love to hear your perspective. And if you've enjoyed this deep dive into the mysteries of the cosmos, don't forget to subscribe and hit that notification bell. Together, let's keep exploring the wonders of the universe, one question at a time. Until next time, stay curious, stay inspired, and remember, the cosmos is full of surprises and the best discoveries are yet to come.